so here in Violent Python, let's take a look at the DNS. And so if I was real happy when I learned how to do this, I learned a little bit of HTML5. So this page here makes a bunch of DNS requests, all to servers that don't exist, as you can see, with just a random 3-digit number. But I was pleased to have that because this is a way to simulate what bots do. When your machine gets infected with a botnet, it will beacon home to the command and control server, typically every 30 seconds or minute or something. And I made it make another request every 1 second so we can see it. Now again, I've got all this extra traffic from Zoom and stuff, so I'm going to filter for DNS. And there we'll see it, and I can just stop it, and you'll see it sends a whole series of a query to server 644 and server 899, and then it gets an answer. And all these answers are saying, I can't find that server. But this is how bots send secret information out from your machine. They have a long, random-looking name of a server, which is stuck into an HTTP request or a DNS request, so it will look like legitimate traffic going through your defenses, but there's data encoded in these random numbers. And so you can sniff it in Wireshark and see the DNS requests, but of course the fun part is to do it in Python. And in Python, you have to use Scapy, and I think last time I tried, Scapy would not work directly in my Mac. Scapy is a little hostile in different environments. You might have to just run it in Linux. I'm not sure. Let's see if I can put it on my Mac. Minus Python 3 -m pip install Scapy. On Mac ZSH, oh no, it says it did something. You just run sudo. All right, I'm talking about something else perhaps. Hey, let's see if it works. So I'm going to make this script, nano DNS, DNS1.py, and here's where I get the data from Scapy. Scapy is the Python library to handle packets like Wireshark. So let's see if this works, and then I'll talk about it if it works. Otherwise, I have to boot up my Linux machine. Python 3 DNS1. And oh, there it looks, I think it's working. Let me open that page again so I have some data. Yeah, okay, good. So let's talk about this script. So what goes on here, we haven't done this before, but you can define a function in Python. You just do def, you have a name of a function and a parameter, and then of course a colon. And all the indented lines are in the function, and when you're no longer indented, the function is over. And so this is the function, and this is the one line of Scapy we're using here. It sniffs for a packet, and if it finds a packet, it calls that function, findDNS. And findDNS looks at the packet and sees it could be any kind of packet, and it looks to see if it's a DNS packet, and if it is, then it prints a summary and a display of the contents of that packet. So this gives you information about the DNS packets ignoring all other packets, so it approximates running Wireshark with a DNS filter. And so when I ran it, you could see what's happening here is, whoa, it shows a question record asking for a server, and then more information here. This whole mess is just a request, and someplace there's going to be a reply. So, and then it's got the Ethernet and the IP address and the UDP. So it's finding the data I want, but it's printing out far more data than I want to see. So I want to clean this up a bit. So let's make a cleaner DNS monitor here as DNS2 that just doesn't print all the extra junk I don't care about. So this is nano DNS2.py. All right, so this is the same, but it only prints the summary instead of all the details. So let's see how this works. And oops, and I'm missing the first character. I didn't paste it correctly. All right. All right, and so now there it goes, making requests. So this is much better. Now I just see the requests and then an answer line. This is pretty good. So now I can quickly see all the DNS requests going by. All right, and so now you can start with that one. If you watch, if you go to this page, there's going to be long random names, but there'll eventually be one of them that just has the flag, if you can sniff these names efficiently. And then there are more and more challenges here which get closer to real botnets. Real botnets have encrypted the data in here, or at least encoded it. And so when you get down to the end, you can encode it with hex, where you just have digit 0 through 9 and letters A through F. But that's not the best encoding. The best encoding is, in fact, base 32. You probably used base 64, which uses uppercase letters, lowercase letters, numbers, and a couple of symbols. But in DNS, you can't use base 64 because if I go to yahoo.com, it works. And if I make it capital Yahoo, it works just the same. DNS does not make a difference between uppercase and lowercase numbers for all DNS servers. It actually varies somewhat. But anyway, you can't really count on telling capitals from lowercase with DNS. So what people do in real malware and other places, if you want to hide data in a DNS record, you use base 32, where you use the 26 letters and some of the numbers and nothing else. And anyway, this has got the flag hidden in base 32 encoding. You'll have to write a script to reverse base 32 encoding to get it. And I've got some HTTP projects here that work the same way. Obfuscated HTTP. This is another thing a lot of botnets do. They send HTTP traffic back that's full of these long random domain names, and in there is your encrypted passwords and information to the bot master about your machine and commands coming back to your bot in the replies. This is encoded or encrypted data being sent out. And so once again, you can quickly write a escapee script that will show you that information, and then you can start seeing when the flag appears randomly, like every 10 requests or so, and find various ways in which the flag is hidden. And I not only did base 64, which works for HTTP correctly, but I actually did base 58, which I learned from Bitcoin. Base 58 is really, I'm not kidding, it's really base 58. The ones is the number of 58s, the next digit is number 50, the number ones, the next digit is number 58s, the next digit is number 58 squared. It does not map neatly into binary, but it's useful for Bitcoin because it's base 64, but you remove all the characters that are going to get confused, like a capital O and a 0, or a lowercase l and a 1. You carefully remove several characters that are very likely to get mistyped, and that's how you create this bizarre thing called base 58. And you can do base 58 in Python. You can do anything in Python. They have written libraries for every twisted purpose. So anyway, there's a few more things you might want to try.